All right, AGS1. Today we're going to talk about 6.4, which is just one kind of shorter concept that combines two different types of transformations. Today we're going to call it flip, flip, turn, because that's really what we're going to be doing. Flipping, flipping, and then talking about turning. The essential question for today, what happens when we combine transformations? So today we're going to do a couple different transformations and see if they turn out to be a different kind of transformation. The two transformations we're going to work with today are definitely rotations, which need a center of rotation. So you have to have like a point that your pre-image is rotating around. I sometimes call this the push pin that you put through the paper, so then you can turn the paper around, you can rotate it. Reflections need an equation of a line to reflect over. So I want you guys to copy this drawing down in your notes. Once you've done that, here's what's going to happen. I've put in these pink dashed lines here. These are going to be our lines of reflection. So the first thing we need to do is label what these lines are. So because this is 3 units up, the horizontal line is 3 units up. This is the line y is equal to 3. On the x, the vertical dash line, it's 1, 2, 3, 4, 5, 6, 7, 8. So this is x is equal to 8 for this one. The first step that we're going to do is rotate. So I'll maybe write this over here. Or not rotate, reflect over the line y equals 3. Now, the way that you reflect over a line is that every single point on the image, so I did this kind of sideways L for us down here. Every single point on this image is going to get reflected over this line here, which you can think of this line as kind of like a mirror. The way that I do this is I think, okay, every single point, like this point right here, is 1, 2, 3, 4 units away from the mirror, which means it's going to go 1, 2, 3, 4 units up. So I know that's going to be the bottom corner of the L over the mirror. Now, here, there's 1, 2, 3 units on the L, so we're going to go 1, 2, 3 units up, so I know that'll be the top corner, and then it's 1 unit over. Also, all of this is like the same distance away, so like this corner right here is going to be 1, 2, 3, 4, 5 units away from the mirror, so 1, 2, 3, 4, 5. We know it's going to be right here. Then this spot is 1, 2, 3, 4 away. So I go 1, 2, 3, 4 on the other side. And then one more unit. Now I have all the sides of this L that I can connect. So color it all in. So if I zoom out, that has now been reflected over the line y equals 3. So this is now the image. And the pre-image is down here. The next step I want to do is take that orange sideways L and reflect over the line x equals 8. So I'm going to do the same process again, but now my mirror is going to be right here. So we'll use a different color for this one. Go green. All of these points are going to get reflected over the mirror line. So I'm going to do it the same way where I just kind of count how many they are away. So like this point right here is 1, 2, 3, 4 dots away from the mirror. So it's 1, 2, 3, 4 dots away over here. Then that next corner is 1 up, then 2 down. This is 3 down. I mean, you can do it just by like figuring out how many units away each corner is, or you can use the mirror reflecting process. Like this is 1, 2, 3, 4, 1, 2, 3, 4. So I know that this is in the right spot. Same way for like this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 away. So then I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'll just go one up. And then I think that's all of them. Just connect the dots. All right, so just to recap what has happened so far. First, this image right here got reflected over this line. So it got reflected here. And then we did another reflection to get here. Now the question I want to ask you guys is if we had just started with this image, pre-image. Oh, that's another thing I should label. Gosh, I'm getting ahead of myself here. In terms of the green L that's on the left, this orange L was the pre-image. So I know it was the image from the first transformation, but then the second we did a second transformation means that it became a pre-image of the second transformation. So the orange L is kind of funny because it's both an image and a pre-image. And then this guy is going to be the image after everything has happened. So, the question I want to pose to you guys is if we had not done this at all, let's pretend we didn't do that. How could you take this L and turn it into this L? Like, how could you do one transformation to get this L up into that one? Let me get rid of all my purple here. Whoops, and my green. If you look at this long enough, you can kind of see that the pink L into the green could be done with one transformation called a rotation. So let's see. If you call this your thumbtack right through the center, it's your center of rotation, and then you take this pre-image, you could actually just rotate it here. I don't know if that's easy to see, but it's like, I wish there was an easier way to show rotations on this, like I could actually take the image and rotate it. But if you kind of think about rotating it from here to here, it would look something like this. And then it would rotate more, you know, another 90 degrees over to here. So it actually is a rotation around this point of 180 degrees. And then if you rotated another 180 degrees, you would be back here with the original L. So the two reflections are the same as one rotation. That's really the main point of this video, is to show you guys that if you reflect twice, it's the same as rotating around the point where the two reflections meet, the two lines of reflections cross. Just going to show you one more example of that. Now we're not going to use any coordinates, but I'm just going to show you guys that if you were first to reflect across line L, so this line right here, let's reflect across that. Notice that this point, if I go straight to the line, like at a 90 degrees, and over to here, this is the same distance as this. Same thing with this point here. If I go all the way across, that this distance is the same as this distance, and it would be the same for this too, because it's like a mirror. Everything in the mirror is the same distance across in the mirror world as our world. So these are all the same. Same thing with taking the red triangle and flipping it over the line M. That like this distance to the line of reflection is the same as this distance to the line of reflection. And like from here to here is the same as from here to here. And here to here is the same as here to here. Now, based off what we did in that first problem, can you guys see? I guess it's a little harder when it's like a triangle that has similar sides. But if you wanted to take just this triangle and turn it into this one, it would be the same. Instead of doing the two reflections, you could just rotate around this point. And you would just rotate, you know, I'm not sure what the degrees would be, but you could rotate from here straight to here. Okay, guys, on your formative today, there's going to be a bunch of work with problems of reflecting and rotating and things, taking figures and points. Please use all the skills of, like, you know, if it's a reflection, each point has to go the distance to the mirror on both sides. And then rotations, they should be fairly simple ones, like 90 degrees, 180 degrees, stuff like that. Okay, guys, I'll help you out in the